Temperature dependence of rate of reaction. Most of the chemical reactions are accelerated by increasing in temperature. Example, N2O5 converted into 2NO2 plus half O2, T equals 0, its moles A, and T equal half time, it is A by 2. So time taken for decomposition of N2O5, 12 minutes at 50 degrees Celsius, 5 hours at 25 degrees Celsius, 10 days at 0 degrees Celsius. So temperature increases, time required to decompose the N2O5 is decrease. So similarly, permanganate ion in presence of oxalic acid in acidic medium converted into Mn plus 2 plus CO2 plus 8H2O, then K1O4 pink color disappeared. Then for a chemical reaction with rise in temperature by 10 degree, the rate of reaction nearly doubled. That is called temperature coefficient. So mu is equal to denominator K at T degree Celsius. When 10 degree raised, then K plus K T degree Celsius plus 10, then rate constant is nearly double or triple. So sometimes triple, sometimes double. So maximum cases 99% reactions are rate of reaction double. So now how to calculate? One shortcut formula given, mu equal to K2 by K1, 2 power delta T by 10. If a reaction temperature is raised from 10 degrees Celsius to 100 degrees Celsius, what is the effect on the rate constant? Then it is nearly 512 times effect the compare with the initial. So K2 is equal to 512 times of the K1. Temperature depends of the rate of a chemical reaction accurately explained by the Arrhenius equation. It was proposed by J.H. Van 't Hoff, but Arrhenius provided justification and interpretation. That is K equal to A into e power minus Ea by RT, where A is Arrhenius factor or frequency factor or pre-exponential factor. It is a constant specific to a particular reaction. R is called gas constant, Ea is called activation energy joule per mole. It can be understood clearly using following simple reaction. H2 plus I2 gives rise to 2Hi. This hydrogen react with the iodine, form a intermediate complex and gives the 2 moles of Hi. Then plotting a graph between the energy and reaction coordinate, then reactant molecule H2 and I2 that will be converted into 2Hi product. Then this H2I2 convert to product forming a activated complex, that is giving by activation energy it convert into activated complex and gives the product. This is a delta H. Reactant convert into product, it is exothermic reaction, delta H of the reaction. All the molecules in the reacting species do not have the same kinetic energy, since it is difficult to predict the behavior of any one molecule with precision. Therefore, Ludwig Boltzmann and James Clerk Maxwell used statistics to predict the behavior of large number of molecules. They plotted a graph between the fraction of molecule and kinetic energy. Then kinetic energy increase, fraction of molecule increase, after that fraction of molecule decrease. So that is called most probable kinetic energy, and they are the most probable fraction of molecule. At that lower kinetic energy, less number of molecule; at higher kinetic energy, higher less number of molecule. But at moderate kinetic energy, the maximum fraction of molecules are having that kinetic energy. Now this can be explained with the temperature effect. Increasing the temperature of the substance increase the fraction of molecule which collide with the energy greater than activation energy. So that is called the fraction of molecule area. Black color and the brown color is the temperature increases, then fraction of molecule increases at that given activation energy. It is clear from the diagram that curve at T plus 10 degree area showing the fraction of molecule having energy equal or greater than the activation energy gets doubled, leading to the doubling the rate of reaction. So that area is double than the T degree Celsius. So second one area is which one? T plus 10 degree. So in Arrhenius equation, the fact E power minus EA per RT corresponding to the fraction of molecule that having the kinetic energy equal or greater than activation energy. So Arrhenius equation. That is K is equal to A into E power minus EA by RT. Taking logarithm on both sides. K equal to, it means ln mean natural logarithm K is equal to logarithm A into e power minus EA upon RT. Ln K is equal to log A into B form can be represented as a log A plus log B. Therefore, ln A plus ln e power minus EA upon RT. Ln K is equal to ln A minus A power x can be represented as x into log A. Therefore, minus EA upon RT into ln E. Ln E value is equal to 1. Therefore, ln K is equal to now I am writing this activation energy first, minus EA upon RT plus ln A. This is y equal to mx plus c form. Actually, it is minus mx plus c form. Therefore, now plotting a graph between y-axis and x-axis. On y-axis, we are taking the ln k. On x-axis, we are taking 1 by t. Then slope is the line is a straight line downward, and the intercept is ln a, and slope is minus EA upon RT. Sorry, the slope is minus EA upon R because 1 by T already taken in the x-axis. So next, this ln actually meaning what is it? Log base E, that equal to 2.303 and multiply with the log 10. So log K is equal to minus EA upon 2.303 RT plus log A. When you are converting log base E to log base 10 form, this is. For this also we can draw the graph. Now on y-axis we will take the log K, on x-axis we will take the 1 by T. Then the straight line downward, then intercept is a log A. In previous graph is a log base E form, now log base 10 form. Base 10 may not be represented, only log represent means that is called base 10, and the slope is equal to minus EA activation energy upon 2.303 into R. Then log K is equal to minus EA upon 2.303 R T plus log A. Based on this, we can write equation at T1 temperature. The equation is log K1 is equal to minus EA upon 2.303 R T1. plus log a. These are constant, therefore I am not giving 1 into log a, equation 1 this is. At T2 temperature, this equation can be represented log K2 is equal to minus EA upon 2.303 or T2 plus log A, equation 2. Now equation 2 minus equation 1, this can be written as log K2, left side is log K2 minus log K1 is equal to, now right side, second equation minus EA upon 2.303 or T2 plus log A, actually minus and required here. Then second equation minus first equation. So in first equation also minus EA upon 2.303 or T1 plus log A. Now log A cancel because minus log A plus log A cancel. Log K2, log A minus log B can be represented log A by B. Therefore, log K2 by K1 is equal to, now EA by 2.303 or is taken as a common. I forgot here or, so you keep in mind EA upon 2.303 into 1 by T1 minus 1 by T2. Log K2 by K1 is equal to EA upon 2.303 or, and 1, that is cross multiply T2 minus T1 upon T1 into T2. This is a final equation. The next, this equation on differentiation with respect to temperature, then it can be represented as a d ln k by dt is equal to d ln a by dt minus d by dt ea upon r and t. So now constant in differentiation is 0, therefore d ln k by dt is equal to 0, and this EA is constant, R is constant, only differentiation with respect to temperature, that is minus 1 by T square, differentiation of that T, 1 by T. Then this can be written as a d ln k by dt is equal to minus into minus plus, therefore EA upon R 1 by T square. D ln k by this dt shifted to right side, therefore multiply EA upon R T square into dt. Now integration on both sides, d ln k is equal to, now those are constant taken outside the integration, EA upon R integration of dt by t square. Then k1 limits to k2, t1 limits to t2. Integration differentiation cancel, therefore ln k limit k1 to k2 EA upon R integration of dt by t square is represented as minus 1 by t and limit t1 to t2. Then after putting the limits, upper limit minus lower limit, we will get the another equation, that is ln k2 minus ln k1 is equal to EA upon R minus 1 by T1, sorry, T2 upper limit minus into minus 1 by T1. Then this can be written as log A minus B, written as log A by B, that is called ln k2 by k1 is equal to EA upon R. Then minus into minus plus, therefore positive term I wrote first, 1 by T1 minus 1 by T2. ln k2 by k1 is equal to EA upon R. Then cross multiply T2 minus T1 upon T1 into T2. This is a final equation. Then when you are converting base E form to base 10 form, multiply with the 2.303. Therefore left side 2.303, right side divided. Therefore log k2 by k1 is equal to EA upon 2.303 R into T2 minus T1 by T1 into T2. This is a final equation.